Thank you for coming back to Garage Time. Today, the 356 is poking out. So I'm going to continue the work on the suspension on this car. Going to do some more inspection and assembly. The whole thing has been overhauled. So stay tuned.
Garage Time.
Last time we worked on the 356, we left off with a VW 256A tool used to check the straightness of the torsion tube assemblies. And since then, I've done a little bit of painting of the suspension components, but I'm gonna go back to check the alignment of the front suspension tubes so that the trailing arms, which have also been checked, are operating in the right plane of motion. This is a Volkswagen tool, but also works on Porsche if you have these adapters. Now, the adapters didn't come in the box that John sent me, and he didn't seem to have them, so I had to machine these little donuts. So they go over the VW tool. Okay, here we are at the front of the car, and these are the tubes that the trailing arms go into. It has this needle bearing here on the bottom one at least, and that's what transfers the load of the suspension onto the car and lets it operate very freely. Now I've already removed the bearing on the upper torsion tube because I needed to measure this area so I could fit this bushing. This is the bushing that I made, and it goes inside here. That's going to allow me to get a good measurement on the tube locations and also how parallel they are. So I'm going to show you how I removed the bearing because I have to remove this one too. Okay, in typical Tom fashion, I made my own puller to get that bearing out. It's really just a piece of metal. It's probably 3/16 thick, and I've created the diameter just behind the bearing. And what happens here is this is allowed to go in on an angle, and then I can pull it up using this hole right here with some welding wire, and then that allows me to put some nuts on here and just extract the bearing this way. This is really thin welding wire. It's the stuff I use for TIG welding. It has this Z-shaped bend in it, so I'm gonna go ahead and put that in like that so I can pull on the back. So lay it down, get it in there. You can see how the plate is making contact with the back of the bearing, only on the bottom and the top, but that should be enough to get it out. And then here I'm just using a piece of drainage pipe PVC. I cut down the height a little bit. This goes over here like that. And then this piece I already had made for the cylinder heads when I was doing the leak down on the cylinder heads for my 912 engine. So this is just a big thick plate. It goes like that. And then at some point the whole bolt will turn. And if the whole bolt turns, you're not actually pulling. So I'm using a few more nuts on the end of this. That's why this is so long. Okay, now it's pretty tight up against the bearing. Bearing is broken loose. Now it's just coming out. So there's the bearing removed. It still has a little bit of grease on it. I want to clean these anyways, so it's nice to remove them and get all the debris out of there. Make sure all the balls or all the needles are clean, ready to move. And also there is another bearing inside. The inside bearing is not a needle bearing. It is a like nylon or Delrin or plastic bearing on the inside. And what I've done is I'm able to put this in and check the fit of the inside bearing. Now, I don't feel a whole lot of wear. In fact, when it goes in, it has good resistance. It feels really nice. I've cleaned all the dirt and debris out of it. So even if I put the torsion arms in, it feels really pretty tight. So I don't think that bearing needs to be replaced. This is a good way to check it. there's a little play up and down, but the bearing, you know, it's probably 7, 8 inches away, so a little play is needed. It feels fine. And the lower one, maybe it is a little bit looser, but it's not bad at all. So this is where the donuts come in. That fits on there like that. So it slips in. So now this inspection pin is very, very tight. There's no play in it at all. And that's what I needed to do to make this fit well, is to make those little donuts. This one fits a little bit looser, but not much. This plate comes with the tool. It's really just a surface plate. It has these 4 ground feet on it with a little handle on this side. This is a strong, heavy cast piece in it. Those feet line up on these 4 ground surfaces. So when you put them together, you can check that these tubes are parallel with each other. We can also check the up and down distances between two. We can put rulers in between here. But what I'm seeing already, and this is why we do this, I'm seeing a little bit of a rocking motion, just like that. So we'll use a feeler gauge and we'll determine how far this is rocking and compare it to the workshop manual to see if this is straight or not. That's about it right there. That's pretty tight. So that is 40, there's 2 gauges there. That's 45 thousandths. The spec book says 31 thousandths maximum permissible out of alignment. So I probably am close, but I'm gonna see about making some adjustments, see if I can get a little closer. I've done a few other measurements too. I'm just laying this kind of digital protractor on here, verifying that the heights are about the same. 0, 0, 0, and that's also 0, 0, 0. This is not that accurate of a measurement, so I'm going to measure the distance between here. Okay, that's 1.967. 1.966. It looks like everything's parallel in this plane, but one of these is not parallel in this plane. And going back, thinking about the suspension arms, I had measured one that was bent. I don't remember what side it came from, but it was the lower arm. And most likely, it's, instead of this one being bent forward, it's most likely that this one's being bent back. Because if you run into a curb or something, the forces are going typically this way. It's unlikely that something hit the tire and pulled it this way. Okay, we're back to the dumbbell method. I didn't think the dumbbell method would work either. Okay, I'm gonna pull the car over and check the other side to learn if this is really just bent on both sides or if it's just localized to the driver's side. That might help me determine what to do next, but I do have an idea. Okay, this side is only 14 thousandths. Okay, apparently this bushing wasn't happy with me for not removing, there's a grease fitting on the tubing there and it looks like I sheared right through it. That's okay, because my idea is to make a new one. Okay, it looks like the passenger side is good and the bushings on the passenger side are also tight. So I feel confident on that side. The only issue is on the driver's side, it seems like that lower tube is bent in a little bit. So I measured 45 thousandths, the spec is 31 thousandths, so there's a 14 thousandths error. And I remember when I measured the torsion bars or the torsion arms, it was also about a 10 to 12 thousandths air. So it looks like if you bend a trailing arm, you probably are also bending the tubes. I mean, I don't know the history of this car, but the fact is it's off a little bit. So the options now are to do three things. I could either do nothing and just live with the 14 thousandths offset. I could take it to a frame rack and ask them to pull my car 14 thousandths of an inch, and they would probably laugh at me and it would cost a fortune. Or I could do the third thing, which is to machine a new bushing that is the inner bushing, the nylon one, machine a new inner pivot that has a slight offset to it. That would correct the geometry of the lower trailing arm to be that of a true tube. Now, the torsion bars that go inside there are very flexible. They don't contact the trailing arm at all. So I don't think that if the tube is slightly bent, I don't think offsetting the trailing arm in the center of the tube is going to make a big difference at all. In fact, that's the solution I'm going to go with. I'm going back to the machine shop to try to take some nylon and offset the hole in the nylon. There's plenty of material to remove from this bushing, so I'm not worried about that. So I'll do the math, but it looks like the distance where the bushing rides compared to the distance where it's measured is almost the same. So if I took off, 30 thousandths here, it would probably make a change of about 40 thousandths here. That might be enough. I'll do the math. I offset this mandrel in the chuck. So now when it turns, it wobbles. Okay, hopefully you can see the difference in thickness. So it's thicker on this portion than it is on this side, and it's subtle. It's only about a 35 thousandths difference in offset, but the wall here is thicker than the wall here. And then of course on the original part, it's even all the way around. I'm going to remove the grease fitting before I put the new bushing in this time. I took all four out because these are dirty and they need to be cleaned up anyways. This is the little scraper tool I made to clean out these bores. I even got the center adjuster out, so the tube is completely clean. And one of the cool features I just realized on this original bearing, I don't know if this is original to the car or if it's been replaced, but it has 4 grooves in it. One here, and then across this way too. And that's to allow the grease to flow in, and then it doesn't go through to the other side. So the grease is forced to go into the center of the bearing and then outward, and that will lubricate the whole thing as it turns. So I have a carbide burr that is round on the end. So I'm going to freehand those grooves. My radius is a little smaller than theirs, but I'm going to freehand those grooves into my bearing just like the original. And I've marked this side, which is the thin side, and that's going to go towards the rear of the car. You got to remember to put this adjuster in first. And I have the grooves here on the side where the grease gets injected into, and then it can't travel through. Well, some of it will, but that's the right orientation. And now we just need to come up with something to hammer it in. I planned for a 5 thousandths interference fit, so hopefully this isn't too difficult to get it in there. It's a tighter fit. That hole closed up a little bit on me when I pressed it in, but that's a good thing. This is, still movable by hand. It'll break in when the car drives. Yeah, it's much better. Still a little space in the same place, but it's better. Much better. Trying some gauges in here. Let's try 24. Yep, 23, maybe it's 22. Let's call it 22, which is less than 31, which is a thumbs up. This is now within spec. And the important thing about this is that these arms are gonna rotate in the same plane. Let me show you. Okay, these aren't the right arms, and I don't have the bearings in yet. I'm just using the tooling. But what happens with these is they need to spin on the same plane. If these are on different axes, then when this one spins, it's gonna have a different location in and out of the car. So these have to spin on the same plane. That's why we check the parallelism of the tubes. These are now gonna synchronize as they rotate. They're gonna be synchronized in the same plane. Okay, I've been thinking about the situation my car's in, and I absolutely should have looked into this sooner, before the car was painted. Although I don't know that I would have done anything different. And I also had the thought that maybe when the arm was bent, maybe that didn't damage the actual tubes. Maybe what created this problem is the bodywork or the welding that was done to those lower supports, the lower torsion tube supports. This side, I remember, had more repairs done than the passenger side. And as we know, when we weld metal, it shrinks. And sure enough, that lower pivot is closer to the rear of the car than the upper pivot. So it could possibly be due to bumping into a curb, or it could definitely be due to the welding that I've done. Now, I'm sure there's going to be some of you who are like, well, you should have done it on a Celette bench. And yes, I totally agree. I mean, I think Celette benches are fantastic. I will say that just because you use a Celette bench doesn't mean you don't have to check this. And the reason why is because Celette benches aren't perfect either. We're looking at tolerances here to get those axes parallel. We're looking at like 30 thousandths on the inside. It's even less where the ball bearing is or the needle bearing is. So in order for the Celette bench to have that precision within 15 thousandths, or I guess the total is 30 thousandths, but plus minus 15, you're not going to get that with a Celette bench either. And if you do weld it on a Celette bench and then you untension it or you unbolt it from the Celette bench, it's going to spring back also. I also think that you still need to be careful, and I think that the way I've done it is probably about as good as you would have had on a Celette bench anyways, to be honest. Also, before the car was painted, I did check the twist. Just like I did on my 911, I did the same procedure to this car. I made sure that the front mounts were in the correct location, checked diagonally from the rear mounts, and I also made sure there was no twist. And I did correct for some twist. When the longitudinals were all taken apart and the rust repair was being done, I bent the chassis slightly using some long lever arms and then welded it when it was in a level position. So I do feel confident that this car will drive like new now. Thank you so much, John, for letting me use this tool. I mean, I think my car is better because of it, even though it's only like an improvement. We went from 45 to I think 21, it's like a 20 thousandths of an inch improvement. I do think that it makes a difference, and it's within spec. I feel better about it. A lot of people will say that cars that are restored don't drive the same as unrestored cars. It's not just one guy who says that. A lot of people believe that once the car is restored, it maybe doesn't have the same feel. It doesn't drive the same way it did when it was new. And these are the little things that contribute to that. These bearings weren't damaged at all when I removed them. So they look like they're in good condition to go back in, but I'm going to be soaking them in some solvent to make sure they're clean. See, they're really nice and shiny in there. Just make sure this grease gets really packed in between the bearings. This is really nice and firm. So I just want to mock things up before I put the torsion bars in. I just want to make sure there's no binding in the full range of motion. Because once the torsion bars are in, everything's going to be pushed down to its low position, and that's typically where things get set up. But I want to make sure when it's in its actual driving position, which is probably somewhat level here, that things are really moving freely. So now there's no play here in that. What did happen though is it just pulled this arm out a little bit. But what I'm really mostly worried about is as this articulates, I don't want to see this arm going in and out. I just want it to rotate smoothly up and down. Because when I put the torsion bars in, this part is going to be fixed and this part is going to be fixed, so there can't be any binding. A day has passed, and last night before I went to bed, I painted the rest of all the front suspension components and located all the parts that I need to assemble the front suspension. Okay, here are the torsion arms fully painted. I have both sides of the knuckles done. One of the arms is still on the car. I already painted that one. The Zerk fittings or grease fittings are here. This is the hardware that's used to attach the torsion bar and also the torsion trailing arms to the bar. There's the rubber stopper here. I cleaned it up. That's the backing plate that I repaired in a previous video. I have the link pins are mostly in the car. These are a few extra parts. I'm not sure why I have those. And these are the actual torsion arms right here. These are the torsion bars, I should say. Now, I tried to put these in the same place. When I took this off, I labeled it lower. So I'm going to put this in the lower position. And I didn't say which was left or right. But given the wear on the ends of the bars, I'm pretty sure I could figure it out. Things that are damaged are like this one is completely stripped out. I couldn't even get the nut off. The threads are all boogered up and it's stripped internally. These are full of paint and I haven't fully cleaned them yet. I'm going to try to get the paint off without ruining the plating on these. Okay, the plan now is to put things together mostly dry without the seals. Do a dry fit check. Okay, the center of the torsion bar has a little bit of a divot in it, and the pointy end of this set screw locks that in place so it doesn't shift left and right. And there's that clamp right there. Okay, I got the clamp here in the slot, and I can put the set screw in it, but now the divot of the torsion bar is on the other side, so I gotta pull it back out again, flip the bar, and get the divot to line up with this cone and also in the threads of the clamp. So before I take it out, I'm gonna lock it in with this loosely. Now I can pull the bar out and flip it. Now you can just barely see that divot. It's just poking through. I did some careful masking here. I just used this link pin here to protect this surface where the washers push up against. You feel that cone centering itself into the divot. The one thing I'm noticing is there's a big distance between the shoulder of the torsion arm and the bearing surface. So the cornering forces are not taken up by this bearing. Just compresses the seal a tiny bit, but that is it. This surface is clean. It has a little bit of machinist blue on there. I made a lot of effort to get this surface perpendicular to the hole on both arms. So when the carrier goes in, it's going to make full contact all 360 degrees around that. So as you load it and unload it, it's not going to wear in just one spot. It's going to wear the entire thing. The workshop manual says to measure the offset between these two surfaces, 6.62 millimeters. I'll try it one more time. This is why no paint goes on this surface. 6.76. Okay, my notes say 5 on the upper with this one, 5 on the inside, 5 on the outside, and then on the lower, it's 6 on the inside, 4 on the outside. These have to be oriented so that they lock in. Yeah, these aren't the actual bolts that go here, but I'm just using them temporarily to lock this down. Now, both of these shims are tight. You know, there's no wobble at all. It'd be helpful if I had a tire on there, but this feels really nice. Now, there is another method by Jack Staggs, and so I'm gonna try that one. Okay, this is what Jack says to do. He says leave the nuts off on this pinch bolt. I have mine loose, but they're not doing anything. And then he said just to, you know, work on one of these arms and draw it up tight, and then monitor the movement up here. So the top one's loose. I draw this up tight, and then I'm looking for freedom up here. Now he says have an extra shim here. If you can stick the shim in there, then it needs it. And I'm holding pressure on the lower pinch bolt, and that's squaring it up to the bosses. We're squaring it up to the link pin. Okay, I was able to get one in there. So I'm going to add this shim to the upper one. Okay, I tightened it up here at the bottom. And now this is a little, I can feel it's tighter. Okay, no way I can fit a shim in there. Okay, same procedure on this one. We put pressure on this and then we check at the bottom. It's loose right now, but then when I pull this tight, this gets tight again. I cannot put another shim underneath here either. So this is when Jack says to stop. If there's a camber issue, you can delete one shim at the most. So the only difference between the book method and Jack's method was one shim on the top. Now, if the camber is too far positive, then I would just remove that shim, and that's going to push the camber in. So I think it's either way. I think both methods work in this case. I had done a great deal of checking all the suspension components. In fact, my shims were right in the middle, sort of 5 and 5. All right, I'm really excited. These are the first parts that I've reinstalled on my Porsche 356. So that's really cool. I'm excited about it. Feel good about the progress made today. Okay, that offset bushing may be a little bit controversial. I feel like I'm glad that I did it. I know that everything's moving really well and not binding. So I'm pretty happy with that solution. You know, the alternative, like I said, was to do a bunch of, basically it's metal work. And I don't know that you can get the metal work after welding to be that tight anyways. So unless you're the factory and you're welding it once, I don't know how else you would do it. So that's it. I'm going to be doing more work on this suspension area with, you know, putting the seals in, re-greasing everything and doing the other side. But I didn't see any point in filming that because it's going to make the video too long. So thanks again for watching, guys, and we'll see you next week. Cheers.